All right, all right. Who's ready to rock and roll? I'm ready to rock and roll. And today we're going to rock and roll about math. And in particular, we're going to talk about the measures of the middle. If you haven't seen my mean, mean, and mode video, check it out. It's the intro kind of to the measures of the middle. But today we're going to talk about the balance point with range and outliers. So we're going to look at the middle. We're going to look at this thing called the balance point. And we're also going to introduce two terms called range and outlier, and particularly how those outliers mess with our measures of middle, and if they even do. Okay, so let's see. Why is tennis such a loud sport? Yeah, because the players are always raising such a racket. Oh, come on, tennis, racket. And also a racket is like a bunch of chaos and loud noises. You gotta love it. Dad jokes at its math jokes. They're punny. Punny. All right, so today's lesson target. I'm going to represent the mean of a set of data graphically as a balance point. This will kind of help you understand mean a little bit better. You're going to see a visual representation of how we take a collection of data, put it on a line plot, and make it balance so you can see, oh, this is why this calculated average makes sense. And we're going to observe patterns in data to identify these outliers. And we're going to determine the effect of this on the mean, median, and mode and range of numbers, okay? All right, let's dig in. Okay, so all the middles. Remember, let's review some ways to measure the middle of data and how data and points impact the middle. So we have mean, median, and mode are the most common ways for us to measure the middle. The mean is the calculated average. And those are the two words we're kind of looking at. Average is the same thing as mean. A lot of your life, you'll hear people say, oh, what's the average? What's my grade point average? What's his batting average? What's his average shooting percentage? So you use that kind of data. Median has two words that kind of help out. It's the middle of the data points, but also you have to sort that data, okay? Mode is the most easily used. It's simply look at all your data points and is there a number that's used more often than other? Or in other words, is there a number that is used the most, okay? All right, so let's do a little vocabulary. Vocabulary is going to be sprinkled in and out of this whole video, okay, instead of doing it all at the beginning. So we're going to start with range, and the range is just the difference between the highest and lowest value. So in other words, if I had data right here and it was collected from, I had a bunch of data points and my smallest number was 3 and my largest number was 9, the range is simply the difference between those. What's 9 minus 3? Or how far apart are they? And so the range there is 6. The distance from our lowest to highest number is 6. That's the range. Okay, so let's take a look at that. So here's some data in a list. So if you didn't watch the mean, median, and mode, I'll just go ahead and tell you real quick. This data is the same from that video. And it's basically, we went to 7 houses in our neighborhood and collected how many Netflix episodes each house watches in a month, okay? And so the first house said they watch 12 episodes a month, and the second house said 10 episodes a month, and so on, okay? So that's where that data comes from. You're going to see it a little bit later and see why this is important. So let's try the range. What is the range? The range is the difference between the highest and lowest value. Well, what is our highest value? It's 15 in this one. Look through. Do you see any numbers bigger than 15? Nor do I. And what's our lowest value? Well, it's 5. All right. So what's the difference? What does difference mean? That means subtraction. All right. The difference is the answer to a subtraction problem. And so the difference between 15 and 5, or the distance they are away from each other, is 10. So our range is 10. It's pretty simple, right? That one and mode, I think, are pretty easy. You just got to find the highest, lowest, subtract, boom, range. All right, so next vocabulary is line plot. All right, so you've seen line graphs, you've seen bar graphs, you've seen pictographs, you've seen all kinds of wonderful ways to measure data. This is the one that describes data as points or check marks above a number line, okay, showing the frequency of value. So they asked a bunch of kids, how many minutes does it take them to eat breakfast? Okay, and so you can look at this 10 right here. At the 10 value right there, you could count how many of those blue dots there, and that would tell you 1, 2, 3, 4, 5, 6, 7. So 7 of the kids said it takes them 10 minutes to eat breakfast. How many kids said 6 minutes? None. How many kids said 0 minutes? 1, 2, 3, 4, 5, 6. Does that mean they just eat so fast that it doesn't even count as a minute? It could be someone who eats just like a tiny, like a bar, and it takes less than a minute, so they chose 0. But it could also mean those 6 people said, I don't eat breakfast, so 0 minutes. All right, so line plot just is a way of showing frequency on a graph. Okay, and the next vocabulary, you're going to use that line plot to understand balance point. This is how on a number line where the data distribution is balanced. So when we have data on a number line and we have a bunch of data over here and a bunch of data over here, it's where we can put, like imagine a scale. It's where we could put this middle little triangle or balance point, where we can put that there so the data doesn't boom, slam one way or boom, slam the other way. All right, so a data point or a balance point is where when we put this, all the numbers on each side kind of balance out so we're even. It's a balance point, which is also going to be the mean or the average. All right, so let's look at mean as a balance point. So remember, mean, the calculated average of data. We're going to use, we're going to take this data and distribute it on a line plot. So let's look at the data. All right, so the data still is this Netflix episode deal, and we're going to now create our line plot. So we look at our line plot and we say, what is the range? That's kind of an important thing to understand first. Our range is, there's our smallest number, there's our biggest number, which means there's not going to be any numbers smaller than 5 or bigger than 15. So we can make our bar graph, our line plot just go from 5 to 15. Okay. Then we place an X for every number on the data set. So the 12, let's put a 12, an X for the 12. A 10, let's put a dot or an X where the 10 is, and so forth and so forth. So you can see as this is going, I'm simply just taking the data and I am distributing it on the number line at its curricular place. So now we have a line plot of data showing how many episodes these families watch per month. Okay. Now what do we do? So now let's alternate sides. In order to solve a balance, to make the balance, we're going to take from one side and the other side, we're going to slowly move these X's to the middle. And we're going to find out how when we get to the middle, that'll be our balance point, where this data is the middle. Okay, which is also another way of finding the mean. So if we were finding the mean, we would have just added those numbers up and divided by 7, right? 1, 2, 3, 4, 5, 6, 7. Correct. But this will show you when we do that, we find out that where our mean is. Let's see if we can figure out what that is. All right, so we just move one from the left over one spot. Then we go to the right side and move one over one spot. Then we go to the left side and move the farthest one that was over on the left one spot. We go all the way to the right and find the one that's all the way farthest to the right, and we move it over one spot. Back to the left, one spot. Back to the right, one spot. Back to the left, one spot. Back to the right, one spot. Back to the left, one spot. It's like watching tennis, isn't it? Back to the right, one spot. Back to the left, one spot. Back to the right. You just keep doing this over and over, alternating sides until you have moved all the points into the middle. And when you do that, you will find that you have gotten the balance point. Okay, I'm going to move some stuff out of the way because my tower is getting so big. So now I keep going. I move this one from the left and I move this one to the right. Okay, and so our balance point is 10. Now remember, if we added up those numbers, all those numbers that were on these data points, it would have equaled 70. And when we divide by the number of values we had, which was 7, 70 divided by 7 equals 10. That is the balance point. Okay, mean and balance point mean the same thing. Obviously, when you have a bunch of numbers, you probably don't want to do these X's every time. So that calculated average helps us understand mean a little bit better, and it's the easier way to do it. This balance point shows us, oh, that's where they all kind of balance in the middle. That's the mean or the average spot. All right, so let's talk outlier. All right, so let's say we go around this community and we are collecting data. An outlier says that there's one that's just like, wow, that data just doesn't make sense. It is way out there and doesn't make sense. So if this one, you look at it in this example, all this data for whatever they were collecting was in this range. And then all of a sudden, this one shows up right here. Okay, like a 9.5. And everything else is like down there between 1.5 and 5. That one's kind of sticks out. So let's say using outlier, let's say we use that same data point and something doesn't seem to make sense, okay? So what if we had a new house that we went and say, hey, let's go check those people. They're new to town and we don't know who they are. Let's figure out what their Netflix episode is. And what if we found out that it was way outside the data point? These people love watching Netflix and they watch 49 episodes a month. Is that going to mess with our mean, median, and mode that we've already figured out? Yeah, it is sometimes. And no, it won't other times. Well, let's check that out. So let's see how it impacts mode. All right, so what is mode? Mode is simply the number that we see the most. Okay, and what number do we see the most here? We see 12. All right, so before that outlier was added, 12 was our mode. And then we added that outlier, and it did not change our mode. Now, if that outlier was the same number as one of these other numbers, then it would have changed our mode, but then it wouldn't be an outlier, would it? Because it would have fit right in this data point. So the outliers really don't change the mode. Okay, so nothing changed. Now the median, yeah, this could impact the median. Let's see what happens. So the median, remember, is we take the data and we sort it. We put it in order from least to greatest, and then we find the middle. Okay, what was the median? So the original one, when we sorted it, because we didn't, if you cover this 49, you say the middle was 10, right? Because we had 3 on each side. Well, now we added 49, which means we need to find a new median. So we find the middle of this data point, and it's 2 numbers. It's 10 and 12 now. So we take that to find the median. To find the middle, when you have 2 numbers, you simply find the mean of those 2 numbers, which means you add up those 2 numbers and you divide it by 2 because that's how many data points you have, and it becomes 11. So what happened with this situation is our new median jumps to 11. So that big outlier of 49 actually dragged the median up. So it did have an impact. It changed the middle of this data point. Okay, and what about mean? Okay, if we have an outlier that's so much bigger than all the other ones, will it change the average or the balance point? Well, yeah, so we have to calculate by adding up the points. So we add up all those numbers, okay? 12 plus 10 plus 15 plus 7 plus 9 plus 12 plus 5 plus 49. Are you guys starting to think what this may change the mean? All right, and then we divide it by the number of values. Okay, and how many do we have now? Well, because we added that outlier, we have 8 values. Okay, so we have to divide by 8. And so when we do that, we get 14.875. So before we added that outlier, before we had this, our mean was 10. We added these up and we divided by 7. All right, so our mean was 10. Now when we add this outlier in, our mean jumped all the way to 14.875. It jumped up by almost 5 full points. So yeah, the outlier dragged the mean up, and it dragged it up a lot. Depending on how big that outlier is, it's how far it'll drag it up. And the same thing of like if you were doing a bunch of tests. Imagine this: you were in high school and you're taking a chemistry class, and all of your scores are based on tests. All right, so you had a 97 the first test, an 88, a 91, an 82. All right, so you got these 4 or 5 scores that are all somewhere between 82 and 95 or 96 or something like that. And then all of a sudden, this next test, you've been sick all week, you missed some classes, you didn't study, you're just in a bad mood when you take the test, and all of a sudden you get a 50. You get a 50 on that test. What is that going to do to the mean in that situation? Well, your outlier of 50 is way different than all those other points, and it's much smaller. It's going to drag the mean down. All right, so it's important to understand how outliers impact that. Let's fill in some blanks, would you? All right, so blank is the difference between the highest and lowest values. That sure sounds like the range. A value that lies outside is much smaller or larger than all the other values in a data set. This is that thing that just is way outside of the values, outside like an outlier. Okay, it doesn't make sense in the data because it's much bigger and much smaller. And that's why a lot of people, to be honest with you, in those situations, they just don't count the outlier because it kind of skews what the middle is, right? So some teachers will say, I've been grading all your grades and there's 10 test scores at the end of the year. We're going to drop your highest, or we're going to drop your lowest test score because that outlier, they don't want it to impact. And some will say we're going to drop the highest and lowest, so it gives us a better look at the middle. Okay, and finally, blank is the point on the number line where the data point is balanced. That's the balance point, okay? Balance point. We did that when those x's were moving back and forth. And what's another word for balance point? Well, it's just the mean, right? All right, I will wrap it up. Jeez. Why did the ballerina quit? Because it was just too hard. Too.